Hey guys, welcome back to 100 Days of Code. Today is day 4, and we're going to be focusing on randomization in Python, and we're going to be learning about Python lists. Now, randomization in any sort of programming language is really useful because if we want to create a game, if we want our program to do something different each time, then we need to introduce a little bit of randomness, right? So we're going to be looking at using the random module in order to achieve this. And by the end of today, you will have learned enough to be able to build this rock, paper, scissors game. So it starts out asking you, the user, type 0 for rock, 1 for paper, or 2 for scissors. So I'm going to go for 0 for rock. And it shows me using ASCII art that this is what I chose, rock. And then the computer chose scissors, and rock beat scissors, so I win. Now, you can run this as many times as you want. If I choose paper and the computer chooses rock, then I win. If I choose paper and the computer chooses paper, then it's a draw. But if I choose paper and the computer chooses scissors, then I lose. So this is a pretty simple game, but we're going to get the computer to play this game with us. And we're going to do that by learning about randomization, lists, and a whole lot more. Can you imagine if you had to play Tetris and every single time the block that fell down was like predictable? You always knew that it was going to be a T and then it was going to be an L. Like, there would be no fun in that, right? So, how do we create this randomness for our programs? Now, in nature and in our everyday lives, it's really easy to create randomness. If you splash some paint on a canvas, that's going to be pretty random. If you take a look at the TV static from the analog TVs, that's also a whole bunch of randomness there. But when we're talking about computers, then these machines are what we would call deterministic. They will perform repeatable actions in a fully predictable way. So, how do we wrangle these machines that operate basically on ones and zeros to get them to create some random numbers? Well, there's a whole bunch of maths that can be applied to create what are called pseudo-random number generators. And the one that Python uses is something called the Mersenne twister. And if you really want to read about it, then you can have a look on Wikipedia and take a look under the algorithmic detail. But to be honest, it's a little bit too much information for anybody, unless you're really interested in these types of number generators. But what I recommend though is a free video from the Khan Academy where they explain pseudo-random number generators. And it's really well produced and it tells you a lot of different aspects of pseudo-random number generation. So have a look at that if you're interested to learn a little bit more about pseudo-random number generators. We've talked a lot about randomness, but let's see it in action. Let's write some code and produce some random numbers. We know that we want to get hold of some random numbers, but we don't really want to implement the Mersenne twister ourselves because it's horrendously complicated using lots and lots of maths and probably it'll take us months to write the code for. So how can we get random numbers? If you think about it, it's a little bit like searching for something in Google. The Google algorithm is horrendously complicated and it's taken them years and years to refine and perfect to such an extent where I think Google knows me better than myself because when I search for something, it always gives me the most relevant results. And if you're questioning the complexity of the Google algorithm, just go to Bing and try searching for something and see how relevant the results are. So they have this super complex algorithm, which we're never going to get a chance to see, let alone understand. And yet, every day we're able to search things on Google and use this Google algorithm to get the things that we want, like the airspeed velocity of a laden swallow. Now we can do the same thing when we want to generate random numbers. Because this is such frequently needed functionality, the Python team have already created a random module. And you can get a direct link to this documentation just by clicking on the link in the description box here. And you can see that it contains a whole bunch of functions that you can use that allows you to generate random integers, so random whole numbers or random floating point numbers. So let's see how we can tap into this random module. We first have to import it. So we write import random. And now we're able to use this random module in our Python code. So we can look into the documentation to figure out how we can generate random whole numbers, so random integers, using this random module from Python. So if you scroll down on this documentation file and you go to the section functions for integers, then you can see a whole bunch of different things that we can do to generate random whole numbers. Now, the one that we're going to look into is random.randint. And this is going to generate a random integer between a and b. And these are the numbers that we have to provide to set that range. So the way that randint works is that it will generate a random number that is greater than or equal to a and less than or equal to b. So basically between this range a and b that we provide, but inclusive of both a and b. So let's give it a go. If we go into our code file and we use the random module, so we first write random. This refers to this module that we just imported, which contains all the code for generating random numbers. And then we write a full stop, which in programming is normally called a dot. So random dot, and then we're going to use the name of that function that we found, randint. So this randint needs some open parentheses. And you can see from the code hints, it's asking us for a, which is an integer, and b, which is an integer. And we already know this is the range that we want. So let's go ahead and give it a range, and I want a random whole number between 1 and 10. So in this case, I've got 1 as the first starting value, so it's going to give me a random number that could include 1, and then it goes up to 10 and including 10, so it means that we will get random numbers between 1 and 10. So let's go ahead and save this into a variable, which we'll call random integer. And now I'm going to print this random integer. And every single time I run it, you'll notice that I'll get a different number, or maybe sometimes the same, but it's a random number between the range that I've specified. Now, I've mentioned that the random module is a Python module. So what exactly is a module? Well, you've seen that we've mostly been writing our code all on the same page in a sort of script style, right? And everything just kind of gets executed from top to bottom. But sometimes your code will get so long because you're trying to create something complicated, and it's no longer possible to understand what's going on in such a large piece of code. What people will do in that case is to split the code up into individual modules, where each module is responsible for a different bit of functionality of your program. And if you have a complex project with many, many modules, then you could have collaboration on your project, right? Lots of people could be working on it, each person working on a different thing. Say if a factory was building a car, it wouldn't make sense for one person to build the entire car, from wheels to axles to the chassis. That's crazy. Instead, you have different people working on different modules, like the tire module, or the chassis module, or the engine module. And then once they put everything together, you end up with the final car, or in our case, the final program. So we know that the random module is a module that the Python team created to make it easier for us to generate our random numbers without needing to get into the complexities of all of the math that's required to generate pseudo-random numbers. But how can we create our own modules, and how do modules work anyways? Well, it's actually very simple. If you open up the file inspector over here and you go into today's task, random module, and you right click on it, you can go into new, and we're going to create a new Python file. Now we're going to create our Python file and call it my module so that I can show you how to create your very own module. Now let's say inside my module, I decide to create a variable called my favorite number, and it happens to be 3.1415. Now, if I want to use this number that I've created in my module, all I have to do is to go back into the task.py, which is the main entry point, at least in this course format. And normally when you're writing code in Python, it might be called something like main.py or app.py, but either way, there's usually a primary file that you use where you write most of your starting and core code. Now, if I want to use the code in my module, all I have to do is, same as the random module, I have to import it. So I'll import my module into this task.py file, and then I can use it by simply printing, for example, my module dot my favorite number. And you can see it's exactly the same way as the random module. We imported it and then we used a function inside it called Randint. And now if I go ahead and print, you can see the my favorite number is printed by using and tapping into this module. Now, coming back to our main task of generating random numbers, let's take a look how we can generate random floating point numbers. So I'm going to go ahead and delete my module and all the related code. You can keep yours if you want, just for revision, but I want to keep everything as clean as possible. So I'm also going to comment out this section where we've got the random integer as well. So how do we create random floating point numbers? Well, let's take a look at the documentation. If you scroll down to this area called real valued distributions, you can see that one way of generating random floating point numbers is using the random.random function. And this is one of the core functions that we use a lot when we're dealing with random numbers in Python, because it is one of the most adaptive functions. It generates a random floating point number between 0 and 1. Now, if you look at these symbols, you'll see that the random number that's generated can be greater or equal to 0. So that means 0 is included in the possibility, but it is less than 1. So 1 is not in the generated random numbers. Now, let's try that out. So we will create a random number 0 to 1. And this is going to be set to random.random. And notice that it's actually exactly the same, spelt the same casing. But the first one refers to the module. And when you hover over it, it should show you it's the module random. And the second one refers to the function random. And this is something that doesn't take any inputs. And all you need to do is to add an empty set of parentheses to activate it. When we're looking at functions such as the randint, we always see a set of parentheses, and it's been used to put in inputs like what to print, or what is the prompt for input, or what is the range for a random integer. But remember that some functions don't take any inputs at all, but they still need the set of parentheses in order to carry out the action that the function is supposed to perform. So let's go ahead and print this new random number 0 to 1. And you'll see that every time I press the print button, it generates a new floating point number, and it's between 0 inclusive and up to 1 not inclusive. So you can use this random number generator, random.random, to expand it. So what do I mean by that? If we multiply this by 10, then you'll see that the numbers that are generated are going to be between 0 to 10 and not inclusive of 10, because we're basically multiplying the lower range 0 by 10, which is 0, and the upper range by 10. 1 times 10 is 10. So then we've shifted this random number generator to create floating point numbers between 0 and whatever it is that we desire. So you can have a play around with that, but you might also discover another function if you look through the documentation, which is a random floating point number generator. So I'm going to call this variable random float, and I'm going to use the random.uniform function. And this function will return a random floating point number such that the number is greater than or equal to the lower bound and less than or equal to the upper bound. So basically, it's going to generate numbers between A and B, inclusive of A and B. So to use that, we would say random.uniform, and then we can provide a number, say 1 to 10 again. And then let's print this random float, and let me comment out the other part. And now when I run this, you can see it almost does the same thing. The only difference is it's not entirely sure, depending on rounding, whether if you will get 10 or not in the random float. But if you want to be really sure of the range, so this is known as a semi-open range, where you have random.random that always includes 0, but may never include 1. And you can multiply it and do whatever you like with it reliably, knowing that. But because this one can vary depending on the rounding of the upper bound, then you may get the upper bound, you may not. So these are all really minute differences. I recommend to use random.random if you can and you understand how it works to extend the range. Now it's time to do some practice and see what you can actually do with random numbers. And I want you to create a heads or tail program. So the idea is that you should be able to comment out all the existing code if you have any, or delete it if you wish. And you're going to create a program that either prints out heads or it prints out tails. And whether if it prints out heads or tails will entirely depend on a random number that you generate. So think about how you can do that, pause the video and give this a go. All right, so how do we do this? Well, we need some conditions, right? We need to know that we can generate two random numbers. One will represent heads and one will represent tails. Now, if we want the numbers to occur at the same rate, then we could, for example, generate a random number that is either 1 or 0. So how can we do that? Well, we can use this Randint function that we learned earlier. So making sure that we've already got import random written up here. And don't worry if it goes gray. It does that because it's not being used. We can now use it, and you can see it turns into normal syntax highlighting color. And then we can say random.randint, and we want a random number between 0 and 1. So therefore we're going to get 0 or we're going to get 1. And we're going to set this to equal our random heads or tails. Now, you can, of course, call this whatever it is you wish, but essentially what we have here is a random number that is either 1 or 0, and we can verify this just by running this a few times, and you can see it's 1 or it's 0. So now, instead of printing it out, let's use an if statement and check if the random heads or tails is equal to 0. Well, in that case, let's go ahead and print heads. But otherwise, the only other option is tails. So let's go ahead and print tails into the else statement. So when it's 0, it's going to print heads. For any other situation, which is only 1, then it's going to print tails. So now let's hit run. You can see we have now a random coin toss. So because it's random, you might see the same thing occur lots of times. But hopefully over 100 times, you will see it's roughly a 50-50 split. So I hope you had fun creating this program using your newfound knowledge. And once you're ready, head over to the next lesson.
For watching the video till the end. Please leave your thoughts below so we can discuss more about the topic. If you'd like to suggest a video that could help the community, feel free to message me on X or Instagram. We also share short videos on Instagram, so make sure to follow us there. Feel free to reach out. We'd love to hear from you, and might even create a video based on your suggestion.